of course, our calculus life is never complete unless we can have an application of what we're doing. So this is going to be an application regarding the human body. So the surface area in square meters of the human body can be approximated using the equation S equals 1 over 60 square root of h times m, for h height in centimeters and m is the mass in kilograms. If you're watching this in fall of 19, it accidentally said weight, but weight is not measured in kilograms. It should say mass. So a child is 125 centimeters tall and has a mass of 34 kilograms. His current growth rate is 3 centimeters per year with mass gain of 2 kilograms per year. Find the rate of change in surface area. I just put this in parentheses. That, of course, would mean with respect to time because both of these are taking place over years, so it would have to be time. So let me rewrite the equation here. So it's h times m to the 1/2 power. And that s is dependent upon two variables, h and m, which are each in turn dependent upon time. So when you want your derivative with respect to time, which you do, you want the rate of change with respect to time, you're going to have to do, let me see here, we want ds delta s over delta t, which I guess I could write ds dt because technically t is the only variable. So it won't hurt anything if you put deltas. It's not, we all know what you mean, but technically since time is my only independent variable, they would be d's. So I would take, let's see here, ds dh dt. So delta s with respect to h times dh dt because t is the only variable, so there can only be one option at that point, and therefore you use d's. Plus, and then the other side, s to m to t. So delta s to delta m times dm dt. Okay, so then I need to be able to find those derivatives. So I want to find the derivative of, I'm not sure that made it any better. I want to find the derivative of s with respect to h. Okay, so I'm going to take this variable, I'm going to take the derivative of this with respect to h. So that means that the m is like a number, it's like a constant. So it'll be a half times 60, so it'll be 160 times a half times hm to the negative a half, and the derivative of the inner part would be m. And then I'll have dh dt. You can substitute in for dh dt because it was given, but let's just go one more step before I do that. And then the next part would be delta s delta m. So that would be the derivative of s with respect to m. So 1 over 60 times 1 over 2 hm to the negative a half times h dm dt. All right, now I was able to find the derivatives of these parts because I was given a formula. But dh dt and dm dt, I wasn't given a formula. But I was given the values. If you look right here, it says growth rate right here. That's dh dt. It was just given. So we're actually just going to put the number 3 in right there. It'll be 3, and then there'll be, let's see, m. We'll figure that out in a second, right? So, but let me just back up and figure that out later. But we know that that number is going to be 3. And then we also know that the other number over here for the m is going to be 2 because it was given right here. So dm dt. So we know that number is going to end up being 2 for this particular student. What else were we given for this student? Well, we were given that the student is 125 centimeters tall and has a mass of 34. So what we're really going to look for is ds dt for this student at 125 and 34. So that'd be 1 over 120, because 60 times 2 is 120, hm to the negative a half times m. But we were told that h was 125. We were told that m was 34, and then m is 34. So if we just use all the pieces that we were given, right? We were given h equals 125. We were given that m equals 34. We were given that dh dt is 3 and dm dt is 2. We can use those pieces to find everything that we were looking for. So if you will, this step right here has the derivative, and then I'm substituting all of it in. All right, and then again, it will again be 125 times 34 to the negative 1/2 times h, which was given as 125. All right, so now let's just find all of that, right? So we find it all with a calculator or with Maple. So I pulled up Maple. Sorry, I forgot to show this to you earlier, but if you want to find the derivative with respect to particular variables, it's quite easy to do. You just name your functions. So I have, and I have multiple functions here going on, so that's why I have brackets and all of that around this. So if we look at the particular one we're looking for, the function was 1/60 square root of h times, I did w because that's the way this problem used to be generated instead of m. So it has a function there, and then I found the derivative right here, and then I multiplied it by 3, and then I multiplied it by 2. So there's the derivative right here, and I substituted 3 and 2 in, and then I allowed the x and y value, or the h and w values, to be 125 and 34. And so when I did that, it came up with this answer, which I did not want. I wanted a decimal approximation, and sure enough, I just said to give it to me in decimals, and it did. Simple as that. I don't know where that 22 was just an accident just now. There we go. So it was 0.044996. So that's that derivative. I used Maple to do this. And it would be, well, let's think. It would be centimeters squared per year. Oh no, I take it back. It'd be meters. So it's in square meters. Even though the formula uses centimeters, must have to do with the way the formula works. So it would be square meters per year. Now, if you want square centimeters per year, you'd have to convert by getting rid of meters. So there's 1,000 centimeters in every 1 meter, and you'd have to do it twice because you'd be getting rid of meters squared. And that would move the decimal 1, 2, 3, 4, 5, 6 places over. So that would be 1, 2, 3, 4, 5, 6. So it'd be 44,996 square centimeters per year. And again, the reason that was square meters is because it was defined that way back here at the beginning. It was defined in square meters, and therefore it's meters squared here. If you want to change it to centimeters squared, you'd have to convert both sets of meters to centimeters.